In this video, we'll go over JavaFX, the basics, and how you can create graphical user interfaces using the Java framework called JavaFX. So this is a new framework that has been introduced, and it's much better than the previous predecessors, AWT and Swing. It is also an excellent example of how object-oriented principles should be applied, because you'll see in the API the library uses these principles very well with all of the inheritance features, and you see it in the class hierarchy. So a little bit of history. So Swing and AWT were the frameworks originally in Java that facilitate graphical user interface creation. AWT stands for Abstract Windows Toolkit. It was good for simple GUI applications. It was prone to a lot of platform specific bugs, and it wasn't as robust and versatile, and hence it was hence Swing components were added to it, which provided the ability to create much better GUI. And now with the release of Java 8, Swing has been completely replaced with JavaFX, which produces much more superior quality GUI. So the basic structure of JavaFX, we basically have our Java application. So what you do when you start writing the program is that you have to create an application, and in there you have to override the stage. What we're using here, the base class is stage, and you're going to override the start method in it. So that's where you will provide all of your implementation. Now the overall layout of any JavaFX application is it's layered. So the stage is the outermost layer, so that's the main parent layer, and on top of that you can create what are called scenes, and you can have multiple scenes. And then above the scene is where you place different kinds of UI elements or nodes, things like buttons, text areas, text fields, shapes, and so on. So that's how it looks. Let me show you a very basic JavaFX application so you know how to get started with it. So the samples, all of the examples that I'm showing you in this video will be made available in the sample code folder. So the names of the Java files will be whatever is basically shown here in the green text box. So that's where you look up for the name of the Java file and then look for it in the samples folder. So I'm going to first look at my JavaFX file. So that's basically a Java program, and here it is. So what is in there? So it basically you're creating the new class which extends applications. So always you have to create your class, your custom class extending application, and within that you have to override the start method, and that's where you provide your specific implementation. The start method basically takes in a stage object. So that's your primary stage, that's the main window that's displayed. Now on top of that you can add your own elements. So here in this case we want to create a button, an OK button, and then we're going to create a basic a scene and then place it on top of the scene. So here's our scene object, and on that scene we're basically placing the button, and then the overall stage is primary stage, that's the variable. So we're setting the title of the stage, and then on it we're setting the scene, which is this scene object that we just created. And then finally, once you've arranged everything that you want on the user interface, then on the primary stage, then you basically say primary stage.show to display the stage. And then the main method itself has nothing. It's basically just the launch method with the default arguments, and this is it's always just that launch method call. So let me show you how it looks when we run this file. So I'm going to run the my JavaFX class that I have pre-compiled. There's a typo in the file name. Okay, so here's how it looks. Here's my primary stage. So basically we have the application. The primary stage is this window that's displayed. On top of that is a scene, and on the scene is this OK button. Whatever title we set for our primary stage is displayed in this top title bar, and then hitting the close button will close the application. So that's how it works. So to reiterate, basically the arrangement is that you have the stage first. That's your the parent or the outermost layer. On top of that, you create scene, and then you can create whatever UI elements you want on it. You can have multiple scenes as well. Now you can have multiple stages as well, and let me show you a demonstration of a multi-stage program. So the file name is called multi-stage. Let me run it first to show you how it looks. It's the class is multiple stage demo. So here's how it looks. So there are two stages now, and when it was originally launched, you saw how the new stage was above the old one, and if you have to close them, you have to close each of them individually. Let me run this again so you see how it looks when it was launched. So the outer window is basically the first one, the primary stage, and above that we added another one called new stage, and then you can close each of them individually. So they're really two separate windows, and you can move them apart and do things with it. So let's take a look at the code quickly to see how this is done. So so again, just like in the previous case, multiple stage demo is a class that extends application. It's overriding the start method. The main method itself has just the launch call. Now in the start method, we are first creating our primary stage and putting things onto it. So we're basically creating a scene, adding a button to the scene, setting the title of the primary stage, and adding the scene object to the primary stage, and then calling show to display it. Next, we want to create an additional new stage. So you can do that by invoking a new stage object, and then you can set its title, call it second stage. You can create a new scene for it, and then add a new button on top of it, and basically set it to this current stage, and then you again call the show method on it. So that's how the second stage window was generated. So the next thing we want to know is what else can you add onto the stage, and what are some of the different UI controls. So here's a little graphic that shows some of the different classes that are available in the library. So we earlier saw stage and how you can create scene, which is basically a composite. It's part of the stage. And it's a composition because a scene cannot exist by itself. It has to be part of a stage. That's the reason you see the composition relationship over here. Then we have different kinds of nodes. The nodes can be part of a parent class, and that parent can be any interface or abstract class. So these nodes can basically be of type shape. It could be images, it could be controls, or it could be panes, and we will talk about panes. There's different kinds of panes that basically allow you to arrange the items in a specific manner. And here's the hierarchy of the different panes. So here's the inheritance hierarchy that shows pane and its specializations. So there's a flow pane wherein the elements will appear in a certain flow. There's the grid pane if you want to arrange things in the form of a grid or a table. There's a border pane if you want to arrange items in the, say, left corner of the stage, or the right corner, or in the center, or the top or bottom. Then there's the H box and a V box. H box basically will arrange your items horizontally. V box will arrange it vertically. And then there's a stack pane where you stack things one on top of the other. So there are these different panes, and you can, based on your user interface needs, you can basically pick one or the other. So again, going back to the layout, so we have our stage, that's the outermost layer, followed by a scene, and on that scene you can have some kind of a container component, a parent component like a pane or a control, and on that you can have multiple nodes laid out based on which pane you're using. So that's how it works. I'm going to show you an example of a button placed inside of a pane this time, rather than just placing it directly on the scene. So we'll look at this program called button in Java. Let me pull that up. Here it is. So in here we are using the stack pane. So we're creating an object, an instance of stack pane, and on stack pane's get children, we're basically, so get children is the way with which you can add. So you can say get children, and to that collection you can basically add new nodes. So in this case we're adding a button to it. Then we're creating a scene object, and onto that scene we are placing the pane on the scene. Previously we had placed the button, but this time so there's only one object that can go into this constructor. So having a pane helps, because now you can have a collection of nodes on it and you place that entire collection onto the scene. So we're placing the pane onto the scene, setting the width and height parameters, and then we're setting some of the basic parameters of the stage, assigning the scene to the stage and showing the stage. So here's how the UI looks. I'll expand it a little bit so the title is visible. So basically it's the button in a pane, wherein now visually you cannot make out any difference, but if you look at the way it's layered, there is a stage, a scene on top of it, a pane, a stack pane on top of it, and then the button is on top of the stack pane. So that's how these layers are arranged. Next, we'll look at how you can display different kinds of shapes. Again, the API offers a number of different shape classes that you can use. We will first show how you can display a circle. Now at this point I want to point out that the coordinate system, the Java coordinate system, is different from our conventional coordinate system. The conventional coordinate system looks like this, wherein the positive x and y axis coordinates are on the right hand side in this right side direction, and the upward direction. Those are the positive coordinates. So 0, 0 is basically at this central location here. Now in contrast, the Java coordinate system, the way it works is your x-axis is here, the y-axis is going downwards, and our 0, 0 is basically the top left corner. So that's where the 0, 0 starts, and then the x coordinates, as the value increases you move right, and for the y coordinates, as the value increases you move down. So it's important to understand that when you're using the coordinate system. So we'll look at the show circle example to see how a circle is displayed using JavaFX. So let me first show you, run the program and show the UI. So here's how it looks. So basically we have created a circle and placed it at a specific coordinate. Let's look at the program to see what those coordinates are. So in order to use these shapes, we have to import some of these packages. So under JavaFX scene shape, there is a shape package. Under that is where we have all of the different kinds of shapes. So we are importing circle for this program. So we are creating a new circle object. We have to set the center x and center y coordinates. In order to be able to draw the circle, we need to provide the center. So in this case, we're saying that the center is 100, 100. So again, remember this 100, 100 is with respect to the Java coordinate system, which starts at the top left corner. So that's the 0, 0. So with respect to that, now we're going to use 100, 100 as the center of the circle. The radius is set to 50. We're also setting some additional features like set stroke. We're going to draw the circle using black color, and the set fill, we're setting the fill color to be null, so there's no fill. Then we're going to create a pane, a regular pane, and on it we're adding the circle. So here you notice we're not using any of the specialized ones, we're just using the parent, the more general pane. We've added the circle on top of it, then we're creating the scene with the pane on it, and then we're creating the stage with the scene on it, and then we're displaying the primary stage. And when this program is executed, you see what we saw earlier. It's basically this program, and as you can see, when I maximize or when I resize this window, the resizing is not affecting the circle, because the circles X and Y, the center point of the circle is fixed at 100, 100. So it's not going to change. The radius is also fixed to 50, so it's not going to change. The circle remains over there. So if we want the circle also to move as we change the height and width of the window, then we need to use what are called binding properties. And JavaFX introduced this new concept called binding property, so that if you have a target object, it can be bound to a source object. So for example, in our case, we have the stage and the circle on top of it. We can bind the circle to the stage, so that when the stage's height and width or some properties change, then the circle also changes accordingly. So so that's what's called binding. The target object is called the binding object, and then it uses what's called a binding property. So I'll show you an example of how this is done using show circle centered. So this will be a circle that's centered on the window at all times. So here's the code. In here again, we're starting with pane. We're creating a pane object, and then we're creating a circle object that we're going to place on top of the pane. Now for setting the circles center X and center Y, now this time we're going to use the new concept called binding property. So circle class is implemented in such a way that these binding properties are available. So the X and Y, center X and center Y, are now binding properties. So it's called center X property and center Y property, and it provides a bind method so that we can bind it with some source object. So in this case, that source is basically the pane's width property and pane's height property. So we are binding it to that, and then we are basically assigning that center X and center Y by using the width of the pane and dividing it by 2, so that way it's centered. And same thing for the Y coordinate, we are taking the height of the pane and dividing it by 2, so that the circle is always centered. And then we still want to set the radius to 50. We don't want the circle to necessarily shrink or enlarge. We just want it always to be centered. And then we're still setting our stroke color and the fill property. And then we're adding this circle to the pane. And then we're creating a new scene object and adding the pane to the scene. And then we're adding the scene to the primary stage and displaying the primary stage. So let's take a look at how this looks when it's executed. So it is the show circle centered class, and here's how it looks. Now if you see, I'm going to so the circle is centered right now, and as you can see, it's basically the way it is centered is by using the width and height properties of the pane. Now I'm going to try and resize this, and as I resize it, you see that the circle is also getting centered. The size of the circle is not changing, the radius is still 50, but then we are able to center it because we are basically using it's bound now to the pane's height and width. So the way binding properties work in Java 8, in addition to your getters and setters, so we have different kinds of properties, and typically we provide a get method and a set method for those properties. Now in addition to that, if it's a binding property, then there is a property getter as well. So for example, in the circle class, we basically have center X and center Y, those are properties. Now we're going to call them, instead of just calling it as a regular int or a double, now we're going to use binding properties for it. So we're going to use the type double property. So it's going to be a double value where it's a binding property. Then we have our usual get method and set method, but in addition to that, we also have a center X property. So that's the property getter. So we have to specify that as well on the classes. Now the binding can happen either unidirectional, which was what we saw in our previous example. It can also be bidirectional, as in the target is bound to the source and the source is also bound to the target. So I'm going to show you two examples here to demonstrate the unidirectional binding and the bidirectional binding. So we'll first look at binding demo, and then we'll look at the bidirectional binding demo. So here it's a simple example with no UI, but just to demonstrate the properties. So here we have two binding properties called D1 and D2, and we are creating it as a simple, simple double property is a type of property that takes in simple values. So basically we are passing the value 1 and 2 to it. So here what we have done is created now two variables, D1 and D2, two property variables D1 and D2, and D1 has the value 1, D2 has the value 2. Then what we are saying is we're calling the bind method on D1 and binding it with D2. So D1 is our target object and D2 is the source object. So we've bound D1 to D2 now. So if the value of D2 changes, then it will also correspondingly change the value of D1. So as you know, originally we set them to 1 and 2, but then after this binding, when you print them out, both the values will be 2. It will be to whatever the value of D2 was. And then if we change the value of D2 to 70.2 and then print it out, then we'll see again this now both D1 and D2, their values have changed to 70.2. So let's look at this. Let's execute this program. So here's our first print statement. After we initialize them to 1 and 2, and then did the binding, now both D1 and D2's values are 2.0, and then we set the value of D2 to 70.2, and correspondingly here you see in the output now both D1 and D2 values are 70.2. So now that was unidirectional binding. Now if you want bidirectional binding, it means it has to be done in for both the variables. So let's take a look at how that's done. So same thing, we are using two double properties D1 and D2 initially set to 1 and 2. Now instead of using the regular bind method, which is what we used previously, we're going to say bind bidirectional with D2. So now this is going to bind both ways, and then here you will see that the first print statement will basically print out 2, 2 because we did the binding, and then we change the value of D1, and then you will see both values get changed to 50.1. Then we'll change the value of D2, and again we'll see that both D1 and D2 are changed correspondingly to 70.2. So let me run this. So here you see that the first print statement both values are at 2. In the second print statement, because D1 changed, both got changed to 50.1, and then in this third statement D2 changed its value, and both D1 and D2 got changed to that same value. So that's how the bidirectional binding works, and depending on the needs of your program, you can do whatever makes sense. Next we'll look at some other common properties and methods that are available for different types of nodes. One thing that's commonly needed is a style, to set some kind of style, and in JavaFX this is done the CSS style, wherein for the style method, inside the style method you basically specify the attribute name followed by the value, and then the next attribute name followed by the value, and so on. So we use the CSS style. And then there's also a method rotate that's useful because you can rotate a node by a certain angle, and that's what we'll see in this node style rotate demo. So here's the code. So in here we're creating a pane object, and then creating a button to be added on top of the pane. Here specifically I wanted to show you style. So you can set style of the button by using the set style method, and in parentheses, like I said, we're basically using the CSS style. So in quotes you specify the attribute type, the attribute name. So in this case we want to set border color, and the value, colon, the value in this case is blue, and then semicolon separate it, and then you can add additional style attributes as well. Like this is border color, but if you want other things in there, like fill color and so on, you can basically look up the library for these attribute names. They have the prefix -fx and then the name of the style attribute that you may be interested in. So we're basically setting the style and adding the button to the pane, and then say you want to rotate the whole pane, you can there's a set rotate method, and you can specify the angle and change and rotate it. Also you can set style on any of these UI components. So say you want to set the style of the pane, so you can specify the border color to be red, and then there's additional attributes, so semicolon separate them. You want to set the background color to light gray. And then once we're done with all of our styling, you create the scene object, add the pane to it, specify the height and width, then set the title of the stage and add the scene to the stage and show it. So that's what's done here in this code. Let's run it. Here's the window, and basically I'm going to try and resize this. So as you can see, the stage is created, the pane is created on top of it, and a button is placed on it, and then the entire pane is rotated by 45 degrees. So you see that it's rotated. We set the border color for the button to blue and the border color for the pane to red. So the pane was set to a specific height and width, and that's what's being used over here. As you can see, the rotation still remains intact, but basically we are able to see the button and the pane in the rotated form. Next, we'll look at some of the classes that are available for styling and that are useful. There's a color class, so basically you can create a color object and use it in for providing style. So basically the color object maintains the red, green, blue values and the opacity, and there are different constructors that can be used in order to create the color object. Similarly, there is a font class, so a font object can be created with the size, the name and the family name. So again, there are different multiple constructors here using which the font object can be created. I'll show you a demo of the of how the font object is used. Here it is. So just like in the previous case, we're creating a circle with radius 50. Now we want to set a fill color, and in order to set the fill color, we have to pass a color object to it, and here we're creating a new color object with specific red, blue, green and opacity values, and then we're adding that circle to the pane. So that's how we're using the color object here. Next, we want to create a label called with the text JavaFX, and we want to set the font for this label. So the set font method basically needs a font object. So here we are actually it doesn't set font can it can take in different font values. So basically we are specifying the family name, the weight, what kind of posture is it, italics, bold, normal, and the size. So we're basically taking in all of these values. This is a static class, so we are able to directly call the font method on this static class and pass it to set font. So that's what we've done here, and then we're adding the label also to the pane. And then we are setting up the scene and the stage with these nodes. So let's take a look at how it looks when it's executed. Okay, so here's the GUI. So we basically have the circle, it has the fill color in light gray, and then we have the label JavaFX, and it has a specific font size and the italics that we wanted. Now there's also an image class. If you want to deal with images and place images on your UI, then you can basically create an image object, which again takes in either a file name or a URL, and then creates the image from it. There's also an image view class which can be used along with the image, and it creates an image view with a specified image object on it. So we'll look at an example of this, of how images are used. We're going to use the show image Java file for this. So let's take a look at the code. Here's the code. What we're doing is we're creating a pane and then setting padding information on the pane, and then the main thing is we want to place an image. So we're going to create an image object using the file name. So our file is us.gif, and it's available in the folder, in the image folder of this current file, where all of these Java file of the current folder, where all the Java files are. So we're going to basically take that image and create an image view, because in order to be able to view it, we need this image view, and then add that image view object onto the pane. Once we've done that, then we can do, you can manipulate and have different views of that same image. That's the advantage of having an image view. We can use that same image object to create a new kind of view, and in this view we are basically fitting the height and width to 100. We are fixing it to that that amount, and then we are passing this new view onto the pane. So we basically want to show multiple images on the pane. It's the same, it's a US flag image, so the same image, but it's being it has multiple views. The first one is the original, the second one is where the height and width is fixed, and then there's a third image wherein we're rotating the image by 90 degrees and placing it on the pane, and then this pane is placed onto the scene and the stage, and the stage is displayed. So let's take a look at how it looks when it's executed. So here's our UI. So basically the first flag is the first image view, the second one is with the constraint height and width, and the third one has been rotated by 90 degrees. So but then the image object that was created once, and then different views were created based off of it. That's all I have in this video. In the follow-on video, we'll show about different kinds of layouts and how you can manipulate those layouts. Thank you.